How many of them are joined? Should they?
It is started.
Like 3 were waiting. Who are the 3? Only we 3.
No.
Yeah, hello everyone. You can start posting your questions. We don't see any questions on the forum. Okay. If you have anything specific to ask, you can ask.
Right.
Till
Yeah.
what they finished? Harmonic oscillator they've completed? Or?
Yeah, they have completed harmonic oscillator.
Okay. So assignments up to what assignments have been evaluated?
So this is the week 10. So
Week 10.
Yeah. Okay. So week 10 content is like live for all of them. So up to 9th, like they're supposed to finish. Yeah.
So you can start typing your questions and then I could answer. I assume that you're following them. Do you have any questions you can ask me? That's why this live session is for. There were no questions on the forum, right?
Yes.
Anything specific you think we need to discuss with them? Think they had any doubts on the forum they asked you or something?
No, I think from last 1 or 2 weeks, so there was no question on that.
I see,
Also.
I see.
So previously, so we
There used to
answered.
be.
Yeah.
Okay.
So we answered the things. But, yeah.
Okay. Everybody is busy with exams, classes. We don't see anybody on live. This was announced when?
Yeah,
Many
this was
times.
announced. Yeah. The week before and then 5 days.
No one has joined, right? Has anybody joined?
Yeah, it is live, right?
Live. We can't type.
No, we can.
They can only type. But we don't see anybody online joined, Bharti.
Yeah, like previously, I think it was showing that like how many people have joined.
Yeah, we don't see anybody joined. Do you see, Bharti? Sarang? You can see how many have joined. We can't see anybody else who has joined. Only 2 watching means one is NPTL, one is you. 3. Okay. I can't see who they are. Okay. How do I see who are all there as participants?
I think previously there was some option how many have joined.
I'm only bothered with the 3 years. Please type your questions. If you have anything specific. Okay. Watching, but they have any questions to ask? Live sessions are usually where they ask some topics or clarification. Because the recorded videos, when you watch, you may have some things which you want to clarify. That's the reason why we have this live session roughly around every 1 month or something. And If you don't have any questions, it's fine. If you want any specific topic to be explained much more elaborately, you can ask me. Unless you ask me, I will not be able to just take off.
Right. Yes.
When is the exams,
In last week of April or first week of May, I think. Maybe. Yeah.
that the registration should close by some time, no? No,
Yeah,
for the
already,
exam?
yeah, like around like registered for it.
Exam.
I think so, yeah.
Okay. I know a couple of people are watching. Unless you say something or you want any topic to be explained, then I can start doing things.
Right.
But he's putting messages for them. We are all familiar with harmonic oscillator, ladder operators, raising operators, lowering operators. Is that right? You know why we call it as a raising and lowering operators? Can anybody type an answer? What is the reason for calling that A as a lowering operator, A dagger as a raising operator, the ladder operator? Do you know why? You know how to construct the wave function, the ground state wave function using lowering operator? How do you find that ground state wave function? Nobody is even messaging, replying to my whatever I'm saying. Are they there? Virtually, they are switched on, logged in, and gone for something else, looks like. Who is joining?
So where it is showing?
Go down, go down, go down. No, no, go down.
Okay.
In the live session, go down there. Oh. Go down. You went up. Here, go down. Go down. Go down. Go down. Go down. Yeah.
This is
This one, three watching now.
yeah. I think one is Bharti itself.
Yeah, I can still wait for some more 10 minutes or something.
Right, right.
If they have any queries. Other polymatrices, identities, and all are there in the
Yeah, yeah,
assignment
yes,
now?
yes.
It's going on.
Yes, yeah.
Have you been playing around with those polymatrices? You know what is the advantage of these polymatrices? polymatrices are they Hermitian? Are they traceless? And what are the property the polymatrices satisfy? What is the property polymatrices satisfy? You know? Virus coming in. So polymatrices satisfy this takes care that the square of the polymatrices are identity, but you also have this matrix. Okay. So using these properties, you should be able to work out what are, exponential of, let's say, 8 times sigma z, what it is, I times 8 times sigma z, and so on. Use these properties and you should be able to work it out. So what you see is sigma z squared is identity. Have any questions on that? Oh, the screen. I did stop share. After that, the background. I'm sure you're appreciating that angular momentum.
Yeah, there's some one question.
Yeah.
He's saying, I have a problem with hydrogen atom and spin.
Excellent. Let me know what exactly is the problem you're facing, Ankit. So spin cannot be explained using Schrodinger equation. Okay. Spin, if you want to explain, we need to go beyond, we have to go to relativistic quantum mechanics. All your Schrodinger equation, the kinetic energy is p squared over 2m, which is non-relativistic quantum mechanics. Okay. So if you want, why do we need to include spin? That's the next question you can ask. We always do physics where we try and look at what the experiments are giving us data. And Stern-Gerlach experiment is one of the experiments where you do see, even when you take the silver atoms at L equal to 0, we do see that two beams are seen when it passes through an inhomogeneous magnetic field. If we want to account for such kind of observations, we have to introduce by hand the spin quantum. Okay. So on top of your position space wave functions, which you write as psi n l m r theta phi, you have to put in another wave function associated with the intrinsic space for the spin space, and you will have a spin part of the wave function. Is that the problem you are facing? Unless you elaborate, I don't know what exactly you want. Please elaborate, Ankit Kumar, what exactly you are not clear about the spin. When I try to solve the problem, I face issue with where I use NLM. Which problem when you are solving? So did you try and understand in Schrodinger equation in spherical polar coordinates, if you try to break the wave function into R dependent piece, theta dependent piece, and phi dependent piece, you naturally get M for the phi dependent piece and L shows up in the theta dependent equation, and N which shows up in the R dependent equation, but N and L are constrained that N has to be at least 1 greater than L, and M has to take values from minus L to plus L. It's coming from the special functions in spin and angular momentum. Okay, so I think I roughly understand what you want. So angular momentum, orbital angular momentum, it has how many components? Orbital angular, let's do even in classical physics. When I say orbital angular momentum, it is an R cross P vector in classical physics, right? R is a vector, P is a vector, R cross P is also a vector. Okay. But in many experiments, there is always a possibility of orbital angular momentum combining with the intrinsic spin space. It's called spin-orbit coupling. Okay. Whenever you want to do such kind of mixing, okay, so orbital angular momentum has Lx, Ly, Lz, three components. Okay, when you go to quantum mechanics, they become operators, and you have the commutative bracket of these operators to satisfy a non-trivial commutative bracket. So this is why you can't simultaneously measure Lx, Ly and Lz. Okay. So all three, they don't commute amongst each other. Only one of them, Lz, in your hydrogen atom, Hamiltonian commutes with Lz, and also Hamiltonian commutes with L dot L. Take the operator form of it. These are all zero. So which means you can write a state as a simultaneous eigenstate of L dot L eigenstate because, and also Lz eigenstate. So if you do Hamiltonian on this, so Hamiltonian on NLM will give you NLM, and Lz on NLM will give you MH cross NLM. L dot L, L squared on NLM will give you L into L plus 1, H cross squared, NLM. Okay. So it's a simultaneous eigenstate of Lz, L squared, and H. What is the Hamiltonian for the hydrogen atom? It is P squared over 2m. Okay, plus the potential energy. Potential energy for the hydrogen atom with the proton nucleus and the electron on the orbit will be minus E squared by 4 pi epsilon naught R. Okay, this is E squared. Correct? Now suppose I add a spin orbit coupling. Okay, I could add a term like L dot S with some coefficient to keep track that I added a L dot S. Okay, so now my question is, I have to put in this additional information about the spin and the corresponding, just like you had an azimuthal quantum number and a magnetic quantum number, I should have S and an MS. Okay. Clearly, you can show that H with Lz with this addition. Okay, so if suppose I call that as the H prime, let's say, the H prime with Lz is not zero. You can check it. You can also show H prime with SZ is also not zero. But what is going to be zero is H prime with Lz plus SZ. That will turn out to be zero. Okay, it's a total angular momentum, which is the sum of both the Z components of the orbital angular momentum, which is meaningful in position space, and spin angular momentum, which is meaningful in an intrinsic space. To account for the Stirner-Gerlach experiment, it's that sum which commutes with H prime. Okay. So you have to start writing eigenstates, not separately as L, M, S, MS. We should try and write it in terms of the total angular. If you are looking at the H prime particle. Is that answering your question? Difficult. Escape key. Get back to our screen. Stop share right there. After that, I have to again go here. Just back down. Yeah, you have any more questions? We don't see the chat here. You understand, Ankit, now what I'm saying? You need to worry about the total angular momentum if you have spin orbit coupling. It's not only for spin orbit coupling. Sometimes, you have a two electron system. Sometimes you have this two electron system where you may have the two electrons to be interacting. Okay. There also you cannot work with just the, if you take electron alone and let's take stationary electron, you can assume orbital angular momentum is zero, but you have to take care of how the spin interacts between the two electrons, and we need to worry about those total spin angular momentum of the two electron systems and so on. So given a problem, you will be forced to take addition of angular momentum to solve the problem, which you'll be learning in the next 2 weeks, the angular momentum addition. Okay. So spin is forced on us in non-relativistic quantum mechanics, and we put it by hand. If you do relativistic quantum mechanics at some point, you'll start seeing that spin comes naturally there. Again, relativistic quantum mechanics, energy is not p squared over 2m. It's Einstein's energy momentum relation which you have to use. And Dirac came up with nicely, he proposed how to look at the relativistic equation for the electron, and spin quantum number emerges naturally. For this course, for this purpose of course, you can assume that the qualities of spin angular momentum are exactly like the qualities of orbital angular momentum. But by that, what I mean is the commutator bracket of Sx, Sy will be IH cross SZ. Then only you can do addition. Okay, otherwise, it's not meaningful. So it still has just like, it's also behaving like a vector with 3 components. Only thing is, it is in an intrinsic space. If you ask what is the commutator of LZ with Sx, it will always be 0 because those two are two different spaces. Okay. Any other question? Anybody else who has any other question? I do see another 2-3 people are there online. Of course, you can ask your questions also on the portal forum. But there you will get answers by email or reply. Here you can you can use the fact that if you type a question, I can immediately answer for you. I still have another half an hour, so I'm around, so you can ask me. If nobody is asking, then I'll sign out from here. In the next 10 minutes, nobody is asking, we'll sign out. Hmm?
3 hours.
That's what it showed even before. But only one is asking. Ankit is the only one who asked, but others are not asking. Okay, if there are no further questions, probably Bharati, I think I will sign out. Is that okay? Let me know. You can put one more reminder to others. Okay. Is that all right? Bharati, we'll sign out now. Going to be 4:40, 4:35. Anything else, Ankit, you would like it to clarify? You want me to work it out on the screen? Please let me know. I can do it. I still have another 15 minutes, 20 minutes to do things for you.
I think two more people have joined, so
Very good. Two more are joined. Okay.
one.
One more has joined. Okay.
Okay.
Okay, so then we will sign out and wish you all the best for your exam. In case you people want any other queries, you please put it on the forum and we'll answer there. Okay?
Yeah.
Bye. Bye.